Nearly there. Thank you for bearing with us.
Oh God, it's like like they're really walking towards it. Okay, so here's on. Don't need Teams open. I can go. Microphone politics for the pump here. That sounds good.
Yeah.
Shots in the middle.
Yeah. That's it. First speaker done.
Oh my God, there's too many bars on the screen. Oh wait. Wait. Why does it start halfway through then? I don't understand. There we go. Oh my God, there's too many. Go away. Too many bars. Stupid things on the screen.
You can copy track. You just duplicate on the screen.
Yeah,
Yeah.
Use your.
Oh, there we go. But then that's probably showing something else. Was that showing the right?
I've got you. Slides. In
Oh.
fact, somehow we can see your next slide. No, no, we can see your presentation screen.
That's because it's.
Yeah.
Wait a minute. If I. Whoop, I didn't mean to do that.
So you want to share that screen? Yeah, there you go.
Amazing.
Looking good. We've learned.
Really get rid of this.
We are ready.
So.
And he usually has an intro.
Do that.
Oh, and you're already spotlighted too.
Yeah,
I think you go for it.
You don't need intros.
Yeah.
Yeah. Cool. So that's awesome. Yeah, so hi, and thank you for inviting me to this. So this talk is about Mongo. I've been quite passionate about Mongo for the past 10 plus years. And now you can use it in .NET using lots of different ways. So we're going to go over two of them. So before we get started, my clicker's not working. No, some practicing. So I'm Kev. I work as a software developer at a company called Cresco, which is based in London, but everybody's remote. I mostly work on C# and TypeScript, mostly building out like APIs for other like partners to connect to us. And I also try to work on a bunch of open source stuff as well, where I'm spare time. And if anyone wants to contact me, I've got like Blue Sky, GitHub, Twitter, X, whatever people call it these days. And I try to throw some stuff on my blog as well. But I'm also a massive MVP, a Mongo champion. So they've sent me some stuff to give away today. So I've got a book on Mongo, modeling for Mongo, some socks, and a bunch of t-shirts. So whoever asks lots of questions can have them. Why does this stop working? Maybe their battery. So we're going to go over a bunch of things about like what is Mongo, the trends of the databases in the ecosystem, what kind of Mongo uses for kind of storing the data and how it stores it in Beason, and what the reasons behind that. And then also go into a bit about document modeling, how you model kind of things in your database compared to relational databases. And then we'll talk about like the usage in .NET, which is the main part, EF Core, and then the Mongo driver when we fall back into kind of more raw queries. So to start off with, Mongo is still kind of trending above like every other kind of document database out there. So it's well ahead of the curve, and it's mostly because it's been out the longest. It's got the most support for lots of different things like graph queries, as well as being like a normal general purpose database for documents as well. But it's nowhere near kind of things like SQL Server or MySQL because they've been there so long. And there's a lot of legacy systems also kind of using them as well. So Mongo is trying to be a multi-purpose document database, similar to like SQL Server or Postgres is like a multi-purpose multi-purpose database as well, but they're more relational. As Mongo comes more for the document side, everything we have is stored in Beason. So that's the structure it stores in kind of on disk. And everything's implicitly normalized. So we don't try to like split things off into third normal form. We just kind of like group everything together. So we'll talk about that later. And then also it's built for the cloud, so it's horizontally scalable as well. So instead of just throwing more resources at it, you just kind of create more shards or more replicas kind of to deal with your load. So Mongo stores a thing called documents in the database, and these are Beason documents. And the kind of like types you can use with Beason are just on screen here. So double strings, objects, arrays, blobs of binary data, object IDs is with the main primary key for Mongo. People use Boolean state. So it's kind of like JavaScript, but it has a bunch of extra types. And this bit gives it a bit more like extra benefit for like performance when you're doing things like dates. So there's no like kind of date inside of like JavaScript or JSON as a type. So being able to store a proper date means we can do like range-based queries like a normal database as well. Mongo kind of like doesn't really kind of have any schema. Well, people say it's schemaless, but it still has some schema. But you don't have to kind of upfront declare your schema all the time, like SQL Server or Postgres, etc. So you can just create your models in your programming language of choice. Obviously, we use C#. And you can just evolve it as you go along, which makes it a lot easier. So you don't have to create like migrations all the time for all your data. Everything what is in your database just looks like your code. There's no kind of disparity with that, which makes it a lot easier to kind of like understand the relationships. But if you want to kind of like validate things that go into your database, maybe you've got two consumers of the database, it's not just going through like your applications like API. You can actually add like JSON schema validation to it as well to just restrict kind of like stuff what's going in your database. So you can either make that do warnings and say like, oh, this is a warning application saying like this is in the wrong structure, or you can just make it so it does never insert or updates documents which violate that. So this is two documents. So we've got a user here and a user there. This one's called Joe, that one's called Kev. They both kind of have these things called object IDs at the top. So this is like Mongo's like kind of default primary key. It's like a GUID, but it's monotonically increasing. So it's better for like storing on disk. But it's also smaller than the GUID as well. So it's better for like indexing as well. But we also got a name property on there, which is a string. We've got an age, which is a number. But we've also got two different properties at the bottom of it. So we've got a GitHub ID, and this one's got a Blue Sky ID. And that's completely valid in Mongo. So you're allowed to do that, and there's nothing kind of wrong with that. And people do this all the time. So people create like polymorphic documents, documents that have different kind of like properties on there, and that's all completely valid. One thing we can do is actually validate. So if you wanted to validate this as well, we could validate the name has to exist, it has to be a string. The age has to exist, and it has to be a number. And we could say like GitHub is an optional property, but it has to be a string. And you can say Blue Sky is an optional property, it has to be a string as well. So if you tried to push like a number into there or a Boolean, it'd also just throw an exception and say, no thanks. So if you want that kind of control, it's there as well. So a bit of document modeling. So documents are usually based on the application usage. So you don't go and look at your database first, like everybody learned at university, and say, how do you break this up into like loads of tables, use a thermal form? We just look at the data like application, say like, oh, what data do we need to kind of show this page or do this bit of functionality for the application? And then we kind of model it around that. And that normally goes together with like how your aggregate route is. And also if you probably want to kind of embrace like the single document autonomy. Yeah. So like when you only want to be able to do actions on a single document, and they all get applied sequentially, so they don't kind of roll over each other. As if Mongo does support transactions, but it's like kind of a little leaks operation you want to do. You want to kind of roll everything up into a single document, so you don't get kind of a concurrency issues. So you can embrace rolling up data and embedding it. So things like if you've got a person with an address or a bunch of addresses, just put them in an array with a document inside them. All times the UTC, like most databases. So things like time zones you have to deal with yourself. And also arrays and documents, subdocuments can all be indexed as well. So there's no kind of like reason why you wouldn't kind of like put like I don't know, an address field in the side of person and then index on the first line of the address or their postcode. That's all completely fine. So for example, we've got like a relational database here about a blog article. We've got an article in the middle which has our ID, our author ID. So the person who wrote it, the title, then the summary and the text. So the author links to an author table with just the name and the bio on it. We have a bunch of comments on the article as well. So we end up with an ID and the article ID and a text for the actual comment. And then for article tags, say like C# or kind of Azure, we have like a linking table in between. And we just have the names of the tags in there, and they're based on these IDs. And so we don't really need all these kind of IDs to join everything together. They're kind of just there just because we've got a relational database, right? You could probably get rid of the tag one, just have the tags just to be in text with the article, but that's kind of not like how the normal form should be. So in the document database, we kind of like look at like the usage. So normally a a blog site looks like this. So you have the article title, the article text, the comments, tags, and the author and the name and the bio. So we just kind of get all that data and just put it into a document, right? So here we've got like a ID here, the title, the summary, the text, what we want to kind of like explain on the article, maybe Markdown or something. We've got the author, and that's a separate kind of document inside of it. Then we've got the comments, which is also an array of documents at the bottom. So we've got a name, which is foo, and then the text, what they're commenting, and then a bunch of tags as well, which are all the strings. And this is completely fine. We could index this article on the tags. We could index it also on the author's name as well, if you want to search for all them authors with the name. And this is kind of how we kind of model our document, our database. So everything related to this article all sits together. We're never going to get like comments on their own about what are not linked to an article, or we're never going to get tags which are not linked to an article. So there's an alternative to this as well. We can have like a hybrid approach. So maybe we've got an author's page, so you can click through onto the article. They could go to the author and they want to know more details about the author. And you can have another collection which actually just stores that extra information, and then we can just have the name of the author and then the bio and then the ID in the actual articles. And then the author's collection can have the title, first name, last name, the bio, and maybe an article count as well in there. And that's perfectly fine as well. So people kind of do kind of both kind of like scenarios. But one of the main things is like you roll up as much as you can into like kind of really it's snag your root really. So that brings me on to that's some basic stuff about Mongo. If anyone know kind of like document databases were, or kind of like Mongo is. So we're going to go into like how you use Mongo with .NET. I assume maybe it's the .NET developer if that's one person. Is everybody .NET? Three handle? I don't know who's online. Okay. Yeah, so the first way you can actually use Mongo is actually just using the Entity Framework provider. And most people who kind of like do any .NET work know what Entity Framework is. Does people know what Entity Framework is? Most people? 50%? So Mongo is Entity Framework is an object relational mapper. So the idea is it takes stuff out your database, it maps it into like kind of your C# code or your poker object or your domain name object, and then you can interact with it, and then you can call save, and it'll save back to the database. So it's got things like what maps things from types. So it understands like you'll have like a certain type in the database, and it'll be able to convert that to a certain type in C# because your database types are not the same as the C# types. They're totally different. And also it has this thing which allows you to track changes inside your object. So when you go pick something out of the database and do a query on it, you'll put it into memory, and then you'll be able to alter them things like the author's first name or last name. And when you call save changes, it'll know that you've changed the first and last name. And it does that by just comparing like a snapshot of it when you call save. It also makes it a lot more productive because you're not dealing with kind of like trying to work out your own changes and everything else, what's going on. It's built around LINQ, so most people know LINQ for C#, so it allows you to just build up expressions and then execute them afterwards. So that's kind of like a given in C# these days. And then it allows you to do like lazy loading, eager loading, and just some query caching as well. So if you've already got it in memory, you send want to go fetch something by its primary key, and you use find, you'll just go looking at it as cache and just give you the one, but it's already loaded as well. So user interface is quite useful, and people are quite familiar with it with things like Postgres and SQL Server, and maybe MySQL. So you can end up with models like this. So we have this is an example of like a insurance policy. So we have a policy record, we have an ID, which is GUID. This has policy number, a policy holder, the premium, what it is at, and some claims on it. And a claim looks like also a record with just an ID, and amount, and a description on it as well. And with all kind of EF stuff, you kind of like just inherit from a DB context. So the Mongo provider is exactly very similar to like the one for SQL Server or Postgres or MySQL. So you inherit from the DB context. You create a DB set, which is your policies, which is linked to your policy object. And then you pass it a bunch of options. So you have a DB context options of the DB context, and then you pass it into the base. And then when you want to kind of configure how the DB context maps to your database, you override this common thing called on model creating. And there's a few different ways of doing that. So you can inherit some interfaces and pass them in as well. But this is kind of just a default one. So here we've got a model builder saying the entity policy, and we're saying we want to map it to a collection of policies. So this is very similar to all the relational ones. You just call to table on all the relational ones. The Mongo one, you say to collection. So very similar. And then also you can set up things like the properties and tell it to do different things with the properties. So we can say like, do we want the property of concurrency token, and just set this as a concurrency token. So to deal with optimistic concurrency. And then the same thing for a row version as well. So you can also set a property for a row version for optimistic concurrency as well. And then when you set this up, you can just plug it into your IOC container. So if you're creating a web application or a hosted service, you can create the builder, and then on the services, you just do add DB context. And this is exactly the same as you do with SQL Server, except for you do options.use MongoDB. You pass in the Mongo client, which is just the singleton what you use for kind of connecting to Mongo, and then you give the database name, and then it just does everything for you. And then to create some documents, we can go get the DB context out of the service. And this is exactly the same as like if you use it with SQL Server. So there's no kind of like learning curve to kind of using the Mongo provider and for EA compared to if you know it for SQL Server. So you can create a policy, and then we can add the policy to our context by calling policy.add. And then we can then do save changes async. Similar, if you want to query documents, we can just use link and do policy.where the prelim is 100 and just to list it. And then that'll just build the Mongo query up, send it to the database, come back, map it all, and then we'll get our policies out. Updating it is very similar as well. So you can, because it's got change tracking on it, we can go fetch the policies. So you can say where the policy ID is what we just passed it somewhere. We get the first one out of the collection. And then if you want to add a claim to it, you can just create a claim in the code, add the claim to the policy, and just call save changing. And because it's got change tracking on it, it just automatically kind of like works it all out. So it's like you've got a new, the claims collections change, and then it just goes and sends a query to the database. So I've got a little presentation of this. I don't know how well this is going to go. It's just put my screen share now. So let me get that back. But I didn't want to open that wrong project. Oh, yeah, wrong project. Who wants to open? Nope. My voice quality is poor. Okay. I'd like to override it though. Yeah, I think it cut off. I'll just share a second. Oh, it is opening. It's just being very slow. Where's the finger? Not that one. So yeah, so this is just a Node application, which is just an API. You can go away somewhere. So this just connects to my local MongoDB. I've got it running Docker. It creates a web application and then just throws the DB context into the IOC container. Is that way? Yeah. It maps a policy group, the API, and then it's got like a post on it, which just passes in policy. I think it passes in a policy, adds the policy to the collection, and then does save changes, and then returns the policy. And I think no one said the ID of it. I think I changed Lola's code. which I should have reverted back. There it is. Yeah, I opened it up on the train and kind of checked it worked, and it did work, but half the code's different. Yeah, so this is just replacing the policy's ID, so you get a unique ID for it. It adds it to the policy collection and calls save changes, and then returns the policy. It has a get endpoint on the actual just policies, and it allows you to pass a query string in, which is called policy number. So you can filter by the policy number. If it's got a policy number, then it passes that in using a where statement in the link. If not, it just returns policies, and then at the end of it does two that say syndicate, so it just executes the query and returns it as an OK. It can also pass in the policy ID, and then you can query by the policy ID, and if it's not there, it returns not found. And then it's got also one that takes the policy ID and a claim. So if you want to add a claim to this this policy, you can post to the /claims endpoint. It goes and finds the policy. If it's null, it's not found on the database. If it is, it goes and replaces the ID and then adds the claim to the policy and then just saves it. So if you go look at, so this is my database running in Docker, and then I've also got the shell run over here. So there's some UI tools for Mongo, but I like this text-based things. So there's no database set up here at all on my local instance. So I'm just going to run this. So that should connect to my local instance. I don't care the browser. So this is just some HTTP files. So that should be running. Yeah. So this is just some HTTP files to just do some post requests and gets requests to my API. So this is going to post like a policy to my API. So I'm going to go run that. And then that'll come back as it's okay. And then here's my new policy ID. And it's got no claims on it because I don't pass any claims. And then I can go over here and just go look at my database again. And it's just magically appeared here. So it's set my database up. It's called demo1. So we can go look at that database. And then we've got a policies collection. And then we can just go find the policies. So that's all happy. And the DB context for that as well is what it's saving to is exactly the same as what we saw on the slide. We just inherit from DB context. We've got a policies, a DB sit on there. And then for the entity itself, we're just mapping to policies. So we're not saying anything else extra. So if we go back to here, we can start querying by, well, we can totally remove this. Well, if we add a few more policies, it might help. So if we look at our database, we'll have 3 policies there now with different IDs. We can go get them all by just calling the policies endpoint. So that returns them all back, perfectly fine. And then if we go add the policy number onto here as well for the where statement, it can filter them down just with link. And then to get a single policy, we can minimize some things with 2 finger scroll. We can just go past the policy ID into here and get that policy. So that'll get a single policy based on its ID. And then we can start adding claims to that policy as well by calling my claims endpoint. So you can post a claim into there. It'll say there's a water leak in the kitchen. And then even if we go into Mongo, we can see that it's just updated this to add a new claim in. And then if you add 2 in there, because I'm very it's just water leaks, we can go find that, and then that'll add 2 claims in there as well. So it's pretty simple to get going. You don't really need to know any of the Mongo query syntax or the update syntax for any of the operators. It just kind of works out of the box as you'd expect EF to kind of work. But like EF for like SQL Server, it does have downfalls, right? So, for example, we're kind of wasting quite a lot of bandwidth here and mapping as well. So when we go post our claims into our collection, we're going to find the policy out of the database, and we're checking if it's not null, and then we're adding a claim to it and then saving it back to the database. And it's really wasteful because, like, if the policy was like, I don't know, massive, it had loads of information on there, we'd be dragging that information out of the database, mapping it all in code to a policy object, adding one single claim, which is tiny, and then saving it back to the database. And there's a lot more efficient ways to kind of do this using like the Mongo query syntax and the update syntax and using their kind of native operators. And this is where you can kind of fall back to kind of using the Mongo driver, similar to if like you're using SQL, you just do the you do the context dot the like policies dot SQL, and it execute like raw SQL in there. So you can do a similar thing on Mongo. So we'll just flip back to my slides, and I think I just stop sharing, present again, and then reshare. Zoom goes run. Yeah, so this is where the kind of MongoDB driver comes into play. So the Mongo driver has been around for like forever, really. So since like Mongo was around, there was an old version of the driver which had everything coupled into kind of one single NuGet package, and it got split out into lots of other packages. So now we have like a Mongo db.bson, MongoDB.driver, MongoDB, etc. for dealing with different concerns. So, as I said, we want to use the Mongo driver for kind of like better performance and efficiency. So it's all kind of the drivers kind of like knows kind of the document nature as well. So the operators, what we have things like push, so you can push into arrays, you can push into a set, so it understands like you can only have a single like kind of object which is equivalent in that set. It also creates less overhead, so we can do operations in the database, get like a response back from it to say if the kind of documents there or not there, or kind of like what is like done. We also have the aggregation pipeline, which is similar to LINQ, but the aggregation pipeline has all the stages for kind of like dealing with document databases, as LINQ is just more general purpose. So, for example, we might want to find where properties don't exist, and not existing isn't like a LINQ thing. You can check if it's not null, but null is a value in Mongo as well as like SQL, but you can have like a field but doesn't exist, for example. You can also like kind of utilize transactions. So on different parts of your code. So maybe you want to enlist certain queries into transactions, but you don't want to enlist other ones. If you use the DB context, it enlists everything in that kind of single transaction when you call save. And you've got the flexibility of using all the query operators and all the update operators. And you just got better full control of the schema. So if we kind of look at it, we kind of still use typed objects in C# for the driver. So we don't usually kind of fall back into like raw BSON. You can do, so you can actually use a BSON document type, which is just like a representation of kind of BSON. But we're not always kind of still use models, normal models. So for a policy, we can create a policy with an ID, policy number, policy holder, premium. So exactly the same as before. And it can have a list of claims on there. And then the claim's got an amount, description. So this is slightly different because you've got more control with the driver of how the mapping works from BSON to the models, and it can also deal with immutable kind of objects a lot better as well than EF, because EF has got change tracking, like the driver doesn't have change tracking, so you can deal with immutability as well. And kind of how it deals with like kind of like the mapping between the database and your code for the models for the driver, you have these things called convention packs. So it has a bunch of convention packs, which are the defaults, which have things like how you create objects, like a certain types of objects, but you can add extra on. So if you want to have all your properties camel case, you just have the camel case element naming convention, and then everything becomes camel case in your database. And if you want to store your enums as strings, so you want to take more space in your database, you can do that by just adding a convention for that as well. And by default, they're stored as integers, so better for indexing and storage as well. And then you just add them to this convention registry based on a kind of expression of the type. So you can say where the full name starts with demo2, but that's just my namespace. And then if you want to kind of override that for any individual kind of class, you can go to the species class map, you call map, and then you can automap it, which tells it to run through all the conventions by default. So if you don't call that, it doesn't apply the conventions. And then you can start mapping things on top of it. So you can say, map the property policyholder to a element name of just holder. And you can also change the actual serializer as well. So if we've got an amount, we can change that to be the decimal 128 serializer instead. The latest version of the Mongo driver stores things in decimal 128. All the versions you store in the strings for backwards compatibility. And then for IOC registration, you can do this kind of manually by just adding a singleton at the Mongo client. You can add a Mongo database in there. So you get the client and then just call get database. And then same thing for the collection. And the collection, you pass in the type to it as well. So everything revolves, but kind of like how Mongo, it is the terminology in Mongo, really. So you have a client, you have a database, and you have a collection. Very similar to kind of how you see it in the console. And then when we want to go create a document, we just create the policy. Well, we get the Mongo collection, we create the policy, and then we just call insert one async, and we pass the policy into it. And doing this is pretty much very similar to like EF. Like there's not much difference except for the terminology. Everything becomes Mongo terminology. So you have insert one async, which is insert. So the insert's a command in Mongo. Collection is Mongo terminology. So like db set. And if you want to insert multiple into here, you just call insert many. But this way, it'll just do operations one at a time as well. So if you have 3 insert ones, it'll do the first one, the second one. If the second one fails, then you'll be in like a dirty state. As if you use the EF provider, when you call save change async, everything will be in a single transaction. So for querying documents, we go get collection again, and then we can call find, and this is you pass an expression, and you can pass in where the ID is a policy ID, and it will convert this into a Mongo query. Very similar to how like Link does it, the Link provider does it. And then you can call first order call async, and it'll execute that. Or you can start using these policy builder patterns. So this is a filter builder. So you can say for the property of ID, we want it to match equal the policy ID. So then this is falling into more how like Mongo kind of sends queries backwards and forwards to the database itself. So this is using just the more typed way of doing it in C#. If you do it in like JavaScript or Java, you end up kind of like having to kind of manually do $eq, which is like a query operators, but this will compile that down for you. And then you can pass the filter into the find, and then it'll just execute. So that means you can build up like a lot bigger like filters. So compared to Link, there's no such thing as like element matching Link. So you can't say like where this like sub object looks like this other thing. But in Mongo you can. So you can say where the premium is equal to 1,000, and the element match, the claims element matches where the filter of the claim is greater than 1,000 as well. And you can do more complicated like matches, which just takes that object and kind of like runs another query on top of it. You can do also text-based queries as well. So you can do filter.text, which will do a text-based query instead. And also, again, that doesn't exist in Link. So there's no way to kind of like do that in Link. And you can also do things like .exist as well. So you can say where the premium exists, which also doesn't exist in Link. Exist checks if the property like exists in the document. It doesn't check if it's null, for example. And then the aggregation query kind of looks like this. So kind of very similar to like Link, how you can chain things down. So you can call .aggregate. You can say match where the premium is over 1,000, group by the policyholder, take the policyholder as the key and then count how many policies they've got, and then match where the policies at the for the holders over 5, and then just project the policyholder. So that'll give you a list of all the policyholders who have a premium over 1,000 and also have over 5 premiums which are over 1,000. Yeah. But this is kind of all like Mongo terminology. So match is like where, group is like group by, project is like select. So that means you can update documents like, well, you can start updating documents using the builders. So you can create a new, for example, when we're creating our claim and add it to our policy, we can create our claim at the top. We can create a builder and say we want to push this claim into this claims collection on a policy. And then we also pass in, so we do an update 1 async. We pass in the matching of it, the filter. So what we want to apply this update to. So that's like your where statement in SQL, for example. So you say the policy ID equals a policy ID, and then we just pass that update into it, and then it'll just do a push in the collection instead. And you can also change the filter into like a builder as well, so you can do it both ways, you know, separate. And then deleting is very similar. You just pass it a filter, which can either be an expression or a builder. Transactions. So by default, it doesn't enlist anything in the transaction unless you specify. So you can go start a session to start off with. So if every operation what you do to the database has to create a session, but it does an implicit session. So you have to create your own session up front. So you can create a session by calling client.startSession. On that session, you can like start the transaction, and then you can start listing things on that session to be in that transaction. So we can do an update 1, we pass in the session to it, give it the thing what we want to do, etc. all the way down. And then when we want to commit it, we can commit or rollback. And this called, yeah, commit transaction. So look at a bit of a demo on that. And I need to reshare my screen. So this has a connection string to my local host again. It adds the stuff into the ISE container, what we saw on the slides. We have exactly the same, this is exactly the same API, but just for the driver. So we map the policies group. On post, we just do an insert 1, so it's pretty much identical. And then we turn back the policy. When we do a query to it, we can just use aggregate instead. So we can aggregate the collection if the policy number is over length over 0. So we pass into the query string. We can just do a match on it and pass in the policy, and then just to list it as a query. The same thing for the ID. We can just do a find based on a single ID. So them are very, very, very similar to just the EF, for example. And then this is where it gets a bit more like kind of clever. So this is a lot more efficient. So we pass in the policy ID, the claim. We change the claim ID to be a new GUID. And then we can just match on the policy ID for which claim we want to push into. And then we can just use the update push and say like, push this claim into this collection. And then that means we don't have to go download everything out of the database and map to memory. So you can then check if the result has matched a single document. So if it's not matched any documents in the database, then that didn't exist. So we can return not found. If it did, we can just return back the claim saying it's happy. So we can just see that working. Yeah, the browser. So all these are exactly the same. So you can do a post to the endpoint, and that returns a server. Wait a minute, I think. Need to register. So I need to tell it to how there's different ways to serialize GUIDs, and they've been trying to move to this standard way of kind of serializing GUIDs for like forever. And now you have to specify which GUID, how you want to serialize all your GUIDs. So you can set this thing in the serializer. So that's very powerful. So we did a post request and we get the policies in the database, so we can do a few of them. And it's all happy. We can go look at our database over here. So we have so this has a bunch of collections, a collection of policies in here, same as the one, and it has all the policies in exactly the same. And if you notice, it's used the Pascal case for it instead of Camel case as well, because we haven't set it to do that. So it's just on the default. Also, we not tell it to create the collection or create the database. It just does that by default as well, like the EF provider does. You can explicitly create collections in Mongo, but on the database as well. And the only reason why you do that if you want to kind of use like time series databases or set certain properties on your collection. So by default, it'll just create you one if it doesn't exist, if you've got permissions. So we can then take from these before. We can then query based on that policy filter, and it'll just brings back one. So that'll use an aggregation pipeline instead. And then that will go fetch all of them back if it doesn't exist. We can also get a single policy out, which is very similar. And then we can also just add a claim to one of the policies. So if you go look into the database, it'll be exactly the same before. So it'll have like three claims, the three policies, sorry, and then a policy with a bunch of claims on there as well. So you just be able to kind of like just write more efficient queries. So for most applications, you probably don't even really care. You can just kind of abstract yourself and like use EF provider. But if you need to kind of like optimize your queries and do more efficient things and drop down into, I don't know, being able to query different things better ways, then this is kind of how you do it. So that slides. So I've got one last thing to kind of go over before I lose my voice, and that's chain streams. So these are kind of part of the Mongo driver, and chain streams are kind of a way to kind of listen to changes in your database and kind of react to them. So they're really good for kind of like getting away from like ETL scripts and things like that. So maybe you've got like an application you're pushing into some kind of data warehouse. You can just listen to changes on your database and push them into the data warehouse. Or you can just create real-time applications with them as well. Like maybe you're just pushing data down to a front end using WebSockets or SQL Fusion.net. And you can do that as well. And these are kind of all built around how the replication works in Mongo by default anyway. So you can listen to lots of different things. So chain streams can be open on the collection, a database, or cluster. They're all read from the op log, so that's the same thing what the replication uses by default. And you can also start in the past. So you can say, oh, I want to listen to changes in my database from half an hour ago, and it'll just give you them in a stream back to you. And also it gives you a resumption token, so you can resume it anytime. Oh, that's annoying. 1 second. Yeah, bonus slides, but only attendees in person. Yeah, okay, there we go. Sorry about that line. Yeah, so you can resume it at any time. So if you need to restart your application and not miss any kind of changes, you can just get the token, save it somewhere, and then when it starts back up, read the token, and then kind of just continue executing what you need to execute. So these are a bunch of things that you can kind of listen to. You can listen to documents. So if documents are inserted, updated, and deleted. You can listen to changes on the collection. So when a collection is created, dropped, an index is created, an index is dropped, the collection's like being modified in some way, like being renamed, or if the shard key's been modified, or if the collection is sharded. And also then if the database is dropped as well, or if it's invalid as well. So if you do something what invalidates the token, then you'll get an event as well. So this is really useful for kind of like, if you're like a DBA, you want to kind of like allow the developers to kind of go write their own indexes and stuff like that for their application. So they can manage the database more, but you want to keep track of like what index have been added all the time. You can start creating chain streams to listen to your database to give you push notifications saying like, oh, this index has been created. Now you've got 10 of them on this single collection, which has only got 3 fields. And then you can react to it instead. So you can get a bit more control. And to kind of do like listen to a chain stream, you can just get the collection, what we saw before, do a watch on it, and then you can just you can call for each async and just keep iterating over it, and it'll push you the changes to it. And this is this next entry method on the cursor, which allows you to stream it down. But you can do other things with it as well. So we can, with a chain stream, it takes an aggregation pipeline to kind of do the query. So that means you can pretty much anything you do in an aggregation pipeline, you can do in a chain stream. So we can create an empty pipeline and we can just add a match to it, say where an operation happened where it's an insert. So these kind of queries will happen in the database. So we send this query to the database. We're not getting all the information in our application, but the database is, we're saying, here's the stuff that we want to the database, and it'll just push down this single stuff. And then we can also ask for things like full documents, so we can get a document when it pushes an item to us. So it'll give you as the change, what's changed, and we can also request a full document. By default, it doesn't give it you. But this full document is just the latest update of that document. So if you open a chain stream for like half an hour ago, and we ask for the full document, it gives us the document now because it's pushing the change to it. So go look the document up and then add it to the actual chain stream and push it into us. So if we had things like, oh, where we've got an update where we change the status of the policy to anything. So there's any change to that property, and we do the chain stream and we go through like opened, investigation, something, and closed. And by the time we get the change pushed to us and it's in closed state, we'll get a load of events coming through, but it'll just be like, oh, the status changed, the status changed, the status changed for these values. But the actual full document will just say close, 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 closed, if that makes sense. You can change that to have a pre and post document, but you have to enable that on a single collection. So you can't just like just send the query to the database. You need to tell the collection to store that information. But obviously that'll create a snapshot all the time and use lots more space on disk. So I got a single demo with this as well. So I just need to share my screen again. So I just need to change this amazing connection string. What's my password in the middle of it? Don't steal my password, thanks. Into this app instead. So we're just going to run the same application what we did before with the driver, and then we're just going to run another application where it just listens to changes. So this one just kind of like listens to a collection, the policies collection where we got an insert, and then we watch the collection based on that pipeline, and every time it just kind of like says it's been created and there's the ID. So we just run that project again, and then I'll just run this over in this window instead. This is the wrong folder. So this should be running in the background, and that's running there. So if we go to our HTTP file again, and we go create some policies, every single time we create a policy, my console app over this side is just spitting out the actual policy ID. So these two applications over here, so this is calling the API. The API is responding saying it's created the policy, and then I've got another thing listening on a chain stream and another process, which is just kind of like getting push them notifications down to it every single time. So that's pretty cool to kind of like be able to kind of react to changes. So for example, like article page before, every time like an author creates an article, we can go push changes to like the author's collection to update their article count, etc. as well. So back to slides. Oops. I'm going to just share it again. So I've only got a few extra things to get through. And this is kind of production features. So everybody I've talked to, loads of people are like, Mongo is not production ready. And it is just a general purpose database like any other SQL Server, MySQL, Postgres, etc. So it has things like indexes, which people are quite surprised with. So Mongo supports B-tree indexes and text-based indexes, vector indexes as well. So you can do all your kind of cool RAG models inside of Mongo now as well. So yeah, you can do single field index, which is just a single property, a compound index, a multi-key index. So if you've got an array of something and it's got multiple keys that links back to that document, you can do that. You can do text-based indexes, geospatial indexes. You can hash kind of monotonically increasing like values, so they're not just in the sequential line. And then that's mostly used for sharding, so you can have a distributed cluster. You can do wildcard indexes as well. So if you want to like index on all the address fields, you can just do address.star, and it'll just do that as well. You can do partial indexes. So if you want to add a query to it, so you don't want to include null values or deleted documents and deleted policies, we might have a deleted flag, which is where it's set to true. We don't want to index them, you can do that as well. It has TTL indexes, so you can put an index on a date, and when it goes over that date, it just removes the document out of the database. Yeah, it's got pretty much every index type you kind of imagine, like a normal database should have. One of the cool things is it has replication by default, so you're expected to run it in a 3-node cluster. So you have a primary and 2 secondaries, what it just replicates data to. And this is for redundancy being highly available, and you can also read from the primaries for kind of better read performance as well. So it kind of looks like this. Your application talks to the driver, that reads and writes to the primary, and then you can kind of get replication down to the secondaries. You can also read from your secondaries as well, and you can do rolling updates as well. So you can like tell the primary to step down, it'll automatically connect to the secondaries. You don't need to do anything. It's just all magic. And then it also has sharding built in as well. So you probably don't want to start off with sharding if you've got low reads and writes. But it allows you kind of, if you've got a high write throughput application, you can start sharding your data out horizontally instead. And then, yeah, this is just for kind of like more kind of high throughput applications. And you choose a shard key, and then the database driver engine just balances it out itself for you. So that's kind of an example. You kind of have your servers, they talk to a router. The routers know kind of like where the data is being placed on all the different kind of shards. And then you have some config servers what keep updating to tell you what chunks are being split up and where they're being moved to on the shards. So the routers actually cache the information. So they'll try to talk to the shard straight away. If you can't find it, I'll go back to the config servers to go get the latest version of the config and then go try to find it again. So it's fairly efficient. So that's pretty much it for my talk. So we went about the documents and how they're modeled in Mongo. It's a document database. The different usages using EF and the driver. So if you're kind of starting with Mongo and you don't really kind of understand the syntax, EF is really good to kind of just get started and kind of get rolling with it. And then we also have production feature of it as well. There's loads of stuff on Mongo on the internet. So Mongo has some amazing documentation. So they've got the docs, which pretty much tells you about all the different driver types for like C#, Java, JavaScript, etc. They also have a university course which covers like things like using it in C#, how to be a DBA, database management stuff, kind of query performance, how to do modeling. There's loads and loads of stuff about that as well. It's all open source, so you can go change the driver yourself. So I've got some contributions to the Mongo DB driver as well for C#. And then there's also, if you don't want to kind of run it in Docker and things, there's actually a thing called mongoplayground.net, which allows you to just do it in the browser. You can just say, this is my seed for my database, and I want to run this query, and it goes and gives you the results. Yeah, that's it. Thank you for listening. Does anyone have any questions? If you have a question, you can pick a sock, a book, or a t-shirt.
You've made a question then. Streaming thing is kind of similar to kind of what functional counting is not.
Yeah. So you could use it. You could. Yeah, so you could listen to all the collections across your cluster, but the problem with that is you'll end up like all your services will just be like referencing your database, a shared database, right?
Yeah.
Which you kind of want to avoid if you're kind of going to more microservices. So and then you've got to always kind of like have everything in the same schema in the database, right? So if your application changes the schema, then it breaks everything else. So I'd only personally use like change streams for like listening to changes in like your kind of bounded context, for example, unless you've got a small application where you don't really care. As like if you want to go more enterprisey, I'd probably use some kind of message broker instead, or kind of like log stream stuff to kind of do that, because they're kind of more geared towards that. This is kind of like you can do it, but it's more like closed scope, and it's a bit more like fragile because it's all based on your schema in your database. Yeah. Do you want a t-shirt or sock or a book?
T-shirt, have you got a big one?
I have some different types. I think I've got, what size? I've got a large or an extra large.
Extra one.
But they are two different ones. Oh no, that's a small. And I've only got a large.
Yeah.
Large?
I'm trying to lose George. Give us ours. Cheers, dude. Give me something to try and get down here, you know.
It's a challenge. Next time I see you.
Yeah, thank you.
Any other questions?
Yeah. So, is really good if you want to optimize.
Yeah.
With queries. If you're not too fussed about optimizing it, is there any benefits to?
No. So if you do really. Oh yeah. Sorry, forgot this one. Yeah. So the question was if we should we use the driver, or does it have any extra benefits for kind of like other than kind of performance and things like that? Not really. For basic applications, I'd say like you could just use the EF provider and just go with that. But like kind of, yeah, it does allow you to do different types of queries inside of it. So if you want to do text-based searches, for example, you'd have to use a driver. So if you want to kind of do that, or if you want to kind of do geospatial queries, for example, you wouldn't be able to use EF because Link doesn't have geospatial queries built into it. So you kind of have to kind of, yeah, fall back into it anyway. But it all depends on your application, right? So if you've just got a basic application, which is just doing some CRUD, you could just scale away with EF very easily.
Does the EF setup work? You probably answered this one as well. Does the EF setup work with document that you showed rather than the version?
Yeah. So the question was like, does the EF work? Where does it work more?
Yeah, from what I remember the example, the EF wants communication.
Yeah. So the obviously the DB context is related, like built around more kind of relational types, right? And even like Microsoft tried to build their own provider for Cosmos DB. So things which are like embedded, so you don't need to do things like .include, because it'll just include it by default because it's part of the document. So it'll just map it all through. As like in a relational database, you have to do .include, and then you just pretty much have a Cartesian project of like all your joins. So yeah, you don't kind of have to do certain things because this doesn't exist, right? That makes sense. So you don't need to like include extra tables because things don't map to tables, they're just mapped to a collection with a single object.
Okay.
But you can't set up relationships between, say I've got like a authors collection and a articles collection. You can't get EF to join them both together. Okay. It doesn't support that. You could do it in the driver by doing lookups, but it's also not efficient. So you can do things like that. And then other kind of things like if you want to change the property names and stuff like that, you can just fall back to doing dot set element name as well in the DB context config. As it in like SQL Server is dot set column name. So there's the naming is different on things to map it being more document oriented.
There was one question as well. Check.
Medium,
Oh yeah.
small,
Appreciate it.
Medium.
different type. Yeah, you should show small. You can track it. What's the
Yeah, I can read it out.
I can get
Yeah,
push in. You have it automatically creating database and collection on the fly. Can you prevent it from doing that and specifically require them to be created through a migration seeder setup? Yeah, so by default, Mongo will create your collections and databases by default. You can stop it doing that by adding permissions in, really. So by default, you can read write to the for the database and the collection, but you can also set only to read and write certain things inside of a collection. So if you don't want it to have like DB kind of owner rights, you can just limit the kind of like the permissions down. So if it tries to kind of create it, it'll just fail if it doesn't exist, but it'll allow it to save items in the collection. So that means you can like refine your kind of like security permissions, really. Yeah. Oh, any other questions? Does anybody want a sock or a book or a t-shirt? One sock.
Single soft. Why is it called Mongo?
I think it's because I think the name came from humongous. So originally, like, so what's the guy? Oh my God, I'm terrible with names. Dwight and Elliot, I think it was, who made DoubleClick, right? They made DoubleClick, sold it to Google, and then they went on another adventure. Oh, they went into their own kind of ventures and did some kind of contracting work. And they kept building the same thing over and over again when this was like some kind of distributed database and cloud platform. So they got back together and decided to like create a cloud platform like Azure or AWS, and it wasn't very successful at all. And then part of that, they had a database operating, which wasn't called Mongo at the time. But people liked Mongo when it was going around, and people wanted to use that instead. And so they kind of like forked that off, made it open source for people, just kind of like everyone could contribute to it. And then it kind of rocketed on like the open source world, and everyone was like, oh my God, this is amazing. And then they just was like, well, this other thing what we're building over there is like crap, so they just left that behind. And then just continued with the building the database. And then obviously they had clients who were like, there was consulting where we required it, and just kept building that out.
If you have a document database with kind of, you can have different fields per document.
Yeah.
You have there. Do you find that ease of use is offset by constantly having to check whether fields exist in the code?
Not really fields exist in the code, but I used it at one company I worked at. We kind of did improvement software, and we modeled the whole estate for the person who died as a document, right? So anytime we actually need to do anything from an estate, we just go drag the whole document into memory, and everything in the database sort of does the whole estate. So the estate is built to provide the deceased person, their assets, their liabilities, their beneficiaries, their estate counts and things like that, and to like kind of calculate all their estate accounts and do all the assets and the liabilities and everything else anyway. Right, so we just had this like kind of aggregate root, which was all this information on the calculation that we just kept saving to a single document, which worked really well because we had like things like the assets were polymorphic, for example. So you had an asset which was like a house, which had an address, had a value. You had like a car, which had like a registration plate, etc. So they all had their own kind of like behavior as part of them as well. But they also had some properties which they shared, which was like the value of it and some of the properties kind of thing, what we used to calculate them for.
And same thing for liability. So if you've got a loan, it's a liability. If you've got, I don't know, rent or something, it's a liability. And same thing for beneficiaries as well. So you need to kind of like have the beneficiaries who is an individual who's receiving some money or the car, etc. But also the beneficiary might be an organisation, maybe a charity or something.
When you're talking about the schema, then do you have to put all those as options within the collect, you know, how
Yeah.
they get a hub thing and you have the other thing and you have to choose blue sky or
Yeah.
you have to put all those
Yeah, but
options. It could be a car, it could be a house, it could be a thing.
Yeah. But there does be an online single collection. So we have like assets and all the assets which are all polymorphic, all the expenses all polymorphic. The beneficiaries were all polymorphic. And that worked really well for kind of that kind of model as well. And that was quite easy to set up using kind of Mongo in a document database. As if we were going to like SQL Server, we'd have like a 1,000 tables. And every time we need everything, we need to load 1,000 tables into memory anyway, because we only have to keep doing the calculations all the time. So yeah. Do you want that?
I'd look at the first.
I'll take the songs, yeah. I'll take the songs, you get a
You want
I'll take some stuff.
to?
Yeah.
Does anybody want a small t-shirt? I also have a book.
I'll do Teams ones. Cheers.
Data modeling and schema design. So
Yeah.
come back.
Thank you. You.
You'll know everything about schema design. Cool. Yeah, that's it. Any more questions?
Yeah. Yes, sure. Thank you very much. We've got pizzas over there. We're still at the greenhouse. So I'll get the Zoom set up for the next book.
Talking, speaker. Yeah, Chris, when you're ready, you can start sharing. Will give us 5 minutes or so. Yeah,
21.
So
Hopefully that's going through to the speakers.
oh, he's still on my laptop. How do I do? Oh, external HDMI. Say something.
Something.
Oh, that's still somehow on my laptop. Okay. Zoom audio. Select speaker. Try again.
How about now?
Yes. Although weirdly quieter, but yes, you are coming from the ceiling.
Right, is that any better?
It is fine. Let's see if we can get you turned up here. I think it's our end now. It's just like turning the speakers up, and I'm gonna want to.
I've got my volume turned up as loud as I can for input now.
Yeah, his quality sounds good. I can hear you well. I think we just need to turn up the speakers here, and I need to get you on that screen as well.
I also have no idea if you can see the screen because it just doesn't tell me after that.
I can see, yes, A Nightmare on ETL Street title.
Cool.
Let's just do not extend. Yeah, that's fine, isn't it? Yeah, that means we can see your slides and we'll be able to see you.
Which is also helpful.
Yeah. That's fine. Oh, what's going to be coming out on the stream? No, that's fine as well. Okay, I'm going to try and turn you around so you can see the crowd. How's that? Well, this is going to fall off if I do something. Okay, I'll see if I can get the speakers turned up.
No worries.
You want them up?
It's pretty fine. I just thought it was a bit quiet. But, oh, is that what it is? Okay. Yeah, there you go. Cool. I think we're ready to go. You ready to go, Chris?
Yeah, ready when you are. So, you're all expecting a
I'm just get them all to sit down first. Well,
yeah, no worries.
Enjoy them.
Is that everybody? Excellent. So I'm hoping you're all expecting a talk on A Nightmare on ETL Street. And yes, it was a deliberate pun. The other way of putting it is a horror story of ETL development gone wrong. So what is ETL? It's the task of taking data, transforming it, and then storing it. So making it one central place of working. So who am I? Well, I've been doing this for just the 25 years, so a little bit of experience. In amongst that 25 years, I spent months rescuing a massive enterprise ETL system. It was handling, at the end of it, about 3 million requests a day, and it was creaking at the seams when I started, and by the end of it, not so much. So this is the story of how we turned horror into hope and what I picked up along the way. So where did this start? Well, the calm before the storm. It started as a simple project. We were just going to have 3 or 4 data sources. Clear goal, these data sources were just going to be taken in, couple of mini transformations, store them in the database. Famous last words, what could possibly go wrong? Answer, everything. In that darkness, that little tiny idea, something was lurking. Our first clue was just a whisper in the logs. We just started to see the odd one or two warnings, an odd entry, a log message that just didn't belong there. It might have been something like 500 error on an endpoint. We started to ignore it, and really we shouldn't have, because that was our first warning sign that something wasn't right. Went on from there to the first omen. That first omen was a single malformed record. It was just a blip. We just shrugged it off. But the system shivered. And that first crack in the foundations started to appear. We were getting data that we weren't expecting, in shapes that we weren't expecting it. The system didn't know how to handle it. Tried to put it in the database, and we weren't clever enough to be using Mongo at this point. We were using standard systems and standard tables. So we were expecting JSONs to be a certain size. And we were starting to get very big JSONs. Hence the arrival of the blob. One day, this new kind of data arrived. Looked fairly innocent. Was just a big blob. But inside it, it was chaos. This one new person that was using the API, everything they were sending us was different every time they were sending it. Some of these things were tiny differences. It might just have been an ID that happened to repeat. It might have been a description that was longer than the field allowed. Some of these blobs were just totally empty. Some were just unspeakable. It was things like 10 million line JSON records. It was impossible for us to start handling these. But it multiplied. It grew. And over time, each one was getting stranger than the last. We were seeing data that where we were expecting an integer, we were getting a float. Where we were expecting a string, we were getting a number. Where we were expecting true or false, the field was missing. Some of them carried secrets, so new things that we could add, but some carried poison. It literally changed every way that we tried to handle it. Then we had that fateful night of a million sources at once. The trickle became a flood. Millions of records hit in one night. Each one of them had their own quirks. Each one had their own little secrets. What we discovered was that the API had been picked up by a newsletter and had been published as a way of storing data for use later. All that meant was our systems just weren't ready to handle it. It trembled. The logs filled with messages. Those messages were getting faster and faster and faster until one day we had, I think if I remember correctly, it was 9 million records tried to enter the system in the space of 4 minutes. Unsurprisingly, the system just fell over. And the horror had only just begun at that point. The trembling caused CPU spikes, memory vanishes. Those nice gentle hums from the server turned into a groan as they began to crash. Yes, we had redundancy. Yes, servers were standing up, but as soon as they'd stood up, it was crashing again. We watched helpless as this just spread. There was nothing we could do because this data was coming from everywhere. Then we had the shapeshifters. They looked the same on the outside. They had a source, they had a user, and they had this blob. The problem was, inside it, that chaos, not one of those data sources was the same as the last. And they were nested deeper and deeper and deeper. And some of them even changed shape within the space of a single night. We could never rely on any of the data being the same. This sounds like the worst possible scenario. But the true face, we started to standardize it. But every time we thought we'd solved a standardization, It fought back with a new way of confusing us. Why were people putting telephone numbers in the email field? Why were people not returning fields that we were saying were essential? We weren't validating it and we weren't enforcing it. It twisted, it split, and it hid fields that we didn't even know were coming in. It just point blank refused to be tamed. It gave us day after day after day of new ways of breaking the system. Then came the next surge. The system was completely overwhelmed. Data poured in, and on that night it was 22 million records in the space of 16 minutes. It was faster than we could handle. The processes piled up. The system groaned and groaned and groaned under the weight. Servers went down. Servers stood back up and immediately went down again. We were just seeing this over and over and over. The logs were filling with errors, so we were literally getting logs so full of errors that the servers were filling the storage on the server just with the log file. The horrors began to crash the server instantly. At one point, a server stood up and 16 seconds later, the server was down. It ended up costing us on that night nearly $20,000 before we realized what was happening. The floodgates opened. A surge, and then another, and then another, and then another. At its peak, the absolute maximum that it received was 144 million records in 3 minutes. The queue grew. The backlog just became a monster that we couldn't handle. Now, yes, this was offloaded to another server using Redis as a caching layer, but it was impossible to process it fast enough. The system just couldn't handle the amount of data that was coming in. So we were facing a race against time. Some of those elements were needed instantly. People were writing to us to use us as a data system for their applications. The pipeline became slow, confused, tangled. Users waited, and then waited some more, and then waited some more. Some users were refiring data over and over and over. The pressure mounted and those monsters just grew bolder and bolder. It became impossible for us to keep up with what was happening. The clock struck midnight. Deadlines had passed. Promises were broken. And the business itself was growing restless. How do we solve this problem? We've got the perfect scenario. We've got more users than we ever imagined. But we can't process the data fast enough. It wasn't just a technical problem anymore. It had turned into a personal problem. If this didn't get solved, the business went under because we couldn't do what we said we could. The data graveyard. Records were vanishing without a single trace. Others getting overwritten. Their original forms of data were lost forever. We had an occasion where one of the shards of the database had been overwritten completely. It was just firing far too quickly. That graveyard grew and grew and grew. The shadows of the data that we were losing were just lengthening time and time again. The trust in the business was lost. On top of that, we were searching for some of these missing records. Like I said, some of it could never be found. There was ghosts in the system, data that would haunt us forever. Some of this data was literally lost forever. Some of it, thankfully, the users could resend, but some of it was one-time data. But there was a turning point. We realized that we could overcome this horror, but we'd have to take steps one by one by one. We began to map these monsters. We began to track the surges, and we began to build defenses. So what did it look like to map the monsters? We started to understand what data was going into the system. We started to look at logs that we were recording of requests in and responses out. The surges, we knew that there was a pattern to this. It turned out that the biggest surges happened in between the 1st and the 5th of every month. So we began to build defenses. We scaled automatically at the start of the month, and we scaled down afterwards. We began to look at how could we create more queue handling. So mapping those monsters, we named the enemies. We had the blob, which was this unrealistic data set. We had the surge, the amount of data that could come in at any given moment. And we had the shapeshifter, that blob that no matter what was happening, the next request might look different from the same user. And then we had the data ghost, the data that was disappearing. Only by giving them names, I mean, this wasn't what we actually called them, but the essence is there, we could begin to defeat the problem. So how did we standardize? Well, we started to look at transformers. Transformers was the first option we looked at, where we built a way of understanding what each individual user was sending to us. Some of these transformers were as simple as we no longer care what the JSON looks like because we're going to allow you to store anything. Some of the transformers were we're going to validate the way that you wanted us to. Anybody that's ever heard me talk before will know that one of my favorite phrases is talk to developers and talk to your customers. That's exactly what we did. We phoned individual customers, we pulled them onto calls, and we discussed, what do you actually want out of your usage of our system? And we built individual transformers for each of the clients that were massively overloading the system. That started to give us data that we could look at consistently. So each source got its own transformer, universal adaptation for your data. The data was validated and cleaned. So, for example, we had one user who was sending us data, and sometimes there'd be an email field, and sometimes there wasn't. But that email field was what they wanted to use as a primary key. If it didn't have the email field, they wanted it to refer to an unknown user. So unknown literally was the user. So we started to validate and clean that. We always had an email field, but we also had unknown. We standardized it for that user with no more surprises hidden in that data. So what did that give us? It gave us clean, predictable data. That started to give us fewer bugs because our system could now understand what was coming in. And over the space of the first 3 or 4 weeks of handling this, those transformers grew and grew to, in the end, we had 2,000 transformers for 2,000 separate customers. Those transformers standardizing the data meant that at least we could trust that the data was looking similar at each given point. The next thing we did was handling the surge. We looked at concurrency. The key thing for us was that we needed to handle this in such a way as the data could be stored as quickly as possible. We would do asynchronous messaging back and forth. We'd allow this to process, but we would also allow the system to create new queues and fire up new servers based on the size of the queue. So we went from initially having, I believe it was 200 queue workers. In those surges, it was allowed to redefine up to 2,000. So it was allowed 10 times the volume. By allowing it 10 times the volume and allowing it to scale vertically as well as horizontally, so it was allowed to select a higher memory usage if needed, it allowed us to process these queues faster. With the transformer handling the first step of does the data look right, and the queues handling the second step, we began to batch those records and process them in parallel. We started to see that once we'd already validated, we were losing probably about 20% of the requests on most evenings. The system began to fall into its fail-safes. It was never overloading anymore, even at the highest peak of hundreds of millions. It kept things safe. By only allowing the set number of batches to run at any given time, it was forcing it to use the maximum amount of queues that it needed to. But as they queued, resources became freed up, which meant we could then reuse the queue. And we were noticing that some of the queues were bigger than others. So we could feed more into a queue because the requests were smaller in those queues. the system stayed fast and stable, even when those data floods hit. I have since spoken to the company I was working with, and they're now dealing with up to 1 billion records in a day that are being entered into this database. One of the things we noticed was that resilience just didn't exist. If the system failed, it didn't do anything other than write a log. So what we had it do was we had it put in delays. So if it was a memory outage, we put in a delay and we asked it to retry. If it was crashing, we'd log, but we'd also re-trigger the same task. By using exponential backoff, we began to realize that we could push queues further and further back, allowing things to take their time and allowing things to be requeued. If it hit 7 failures, which is the number that we had it in a dead letter queue. This meant that by the time we'd cleared out the first 20% by ensuring that data that we wanted coming in was clean, and then we cleared out another 30 or 40% of the surge by allowing it to naturally scale, we were now down to resilience resolving another 20%. So we'd actually solved 70% of the problem at this point. So how does it work? If it fails, try it again, up to the safe limit. It happened to be 7. We logged it in the database, and we allowed us to review those later. But the key thing was we were now not losing any data in the system, because if it failed, the failsafe queue, the dead letter queue, allowed us to go and look again and find out why it failed, because it was storing the original request, the response we sent back, and the stat trace of what had happened in the process. What that meant was that those temporary small glitches didn't cause permanent data loss. Persistent problems were pretty easy to spot. Like, for example, the time that we spent looking at one person's problem to discover that we had a typo. We were looking for an email address with 2 E's at the start. And that simple typo fixed another 10% of their issues. So, never losing that data, we were able to start creating versioning. What we were noticing is that some of the clients were overwriting data but hadn't told us that that's what they were doing. So we discovered through looking at varying different things, what was happening was we were getting almost event-driven systems that were giving us every update from their systems. What we should have been doing was storing versioning of this. What we were trying to do was overwrite. So they were coming back to us and saying, well, I wanted to go back to one from 30 requests ago, but you never told us that. So allowing us to implement the audit trail and allowing us to implement the versioning meant that we'd solved another 10% of the problems. At this point, we were down to just 10% of the issues. The remaining 10% of the issues followed from having versioned, logged, and tracing back these issues gave us no more ghost data. So what was left? What was left was users who didn't actually know what they wanted the data to do yet, and they just wanted to store everything. So how did we handle that? Monitoring. We put monitoring in place. We gave ourselves logging, metrics. We even had it alerting us when something was happening that wasn't expected. That monitoring meant that on a user by user by user basis, we could divert those logs to an individual developer that was handling that user's needs. What that gave us the ability to do was proactively contact the customer and say, hey, you're sending us this new thing. Do you know what you want with this yet? Do you want us to just store it? Is this a mistake? It gave us the ability to start those conversations. Every single action was logged. We completely, at this point, moved to a full event-driven architecture. So an event was started by their data hitting. Our system created events of its own. We logged their events and we logged our events. We could track over time everything. We could replay anything because it was just stored over and over. At this point, we started to introduce MongoDB as the option for storing this, which again solved more of the issues. It gave us the ability to have documents that we no longer cared what it looked like because the document was just stored. It stored it in MongoDB and using the drivers that were available to us. At the time, it happened to be PHP that we were using. By using the drivers that were available to us in PHP, we were able to start taming more of that data down. So what did this give us? There was nothing left that was hiding in those shadows. By building up and building up what sounds to be simple, easy processes of monitoring, of modifying the data, of validating, all of these things began to solve the problem. So where does that leave us? The system was saved. The monsters were gone. The data just flowed, and the team were celebrating this win. So often as developers, we'll look for complicated solutions to something. I know I'm guilty of this. I'll look for the most complicated version of solving a problem, mainly because that's how my brain works. I'll think of the most complicated path of, well, what we need to do is we need to split it off in 10 different directions. And if this happens, we need to do that. And if that happens, we need to do the other. But just by taking it back to the absolute basics of handling an ETL system, it gave us the ability to implement simple systems that should have been there from day one. The one thing that we did discover, and this was a discovery that came actually after I'd left, was that the original code that this ETL was built on was originally just a proof of concept. It was never supposed to have been the production system. What that also highlighted was a new problem. That highlighted the problem of source control. That highlighted the problem of them understanding their own systems. So I went back and I helped them to implement new systems that allowed them to control better their source. So what was the key takeaway for me? The key takeaway for me was, one, if stuff goes wrong in code, don't panic. The worst that can happen, well, you lose some data. In 99% of cases, you've either got a copy of that yourself or the user has. Two, talk to people. By talking to people about what was happening at any given moment, it gave us the ability to plan this more accurately for the usage. Three, if something gets put out publicly about you, expect surges. We didn't. We thought that this was just going to be a little thing, nice little article that spoke about us. It wasn't. It took the business from a few million requests a year to nearly 1 billion requests a day. And four, engineers will often panic in a scenario and throw everything they can at a situation. Taking a step back and realizing that the situation isn't going to get any worse than it already is, the system's already broken, gave us the ability to think logically, gave us the ability to take the problems little by little and fix them little by little. We picked the customers, obviously, based on income from them as which customers to face first. But sometimes the choice was based on how quickly can we fix this? If a customer was giving us £1,000 a week and it was going to take us 10 minutes to fix it, well, we might as well spend the 10 minutes. If they're giving us 20 grand a week and it's going to take us 4 days to fix it, then maybe we prioritize that one. But prioritizing the bugs meant that we could do this step by step, and prioritizing the actions in the order that the ETL was working meant that we could see the progress step by step by step. Now, I'm deliberately leaving us in a position of plenty of time for questions because I know that this is primarily story-based. This is primarily around the idea of, hey, I screwed up, here's the steps that I took to get out of it. But I think we can open this up as questions because I'm sure we've all been in similar situations. And as I said, conversations help. So has anybody got questions that they want to ask or problems that they faced around this, and how did you end up solving some of these problems?
Anybody in the room? I just went to unmute myself and realized we've not been on mute the whole time. No questions in the room. See online. No, nothing on there. I don't know if I missed some like really important context, but what does the system do? It takes all of this data. What does it do with it? And generally, it's really critical.
So I didn't actually say what this was. So this is a data warehouse. In effect, it takes data from customers, puts it into our data warehouse, and then allows them to use front-end nodes to drag and drop around to process that data in new ways. Effectively, it was giving non-technical people the ability to produce very technical output from data. And the best part was the data was so different from customer to customer that we had to, in the end, just get to, we'll just take whatever you want. What you do with that is up to you. We'll just store it.
Yeah.
Did you find that having to write a transformer for each customer, do you think that's scalable or workable if, you know, the company explodes even further?
So is it scalable? There are two ways of looking at it. One, it can be scalable if you build it into the initial onboarding process for any given customer. Two, what if the customer changes it partway through and doesn't tell you? So the end result was initially we started by building a transformer for each customer to solve the problem. The end result was actually building a system that, rather than writing one transformer for each person, we actually allowed them to build the transformer themselves. So we gave them a front-end system that allowed them to change how we stored the data for them, as well as how they got the data back out again.
Right. Makes sense.
Yeah. Anything else? Cool. No more questions in-house.
Any questions online? No, nothing on the chat.
Thank you very much.
Yeah, thank you. Do you get any common question? You said there's a lot of time for questions. You usually get, is there an obvious one that we're missing?
So the main question I get asked is, how the hell do you handle a billion rows at once? Answer: lots of hardware, lots of late nights. Basically, the data was so unique. I mean, we were having data from major corporations. You're talking like NASA's photography was going through our system for processing. You're talking people like Microsoft used it for a short time for processing stuff that was being fed into OpenAI's, well, their version of OpenAI. But the data was so different. 1 minute we could be dealing with audio data, the next we could be dealing with video data, and the next we could be dealing with huge chunks of text. We could be dealing with pictures. And basically we got to the point where we had 6 different databases that were holding different types of information. If it was video or audio, it was referencing an S3 bucket. And it was just a link to an S3 bucket, which really made that one easy because it was just a couple of references in the database and then an S3 link. When it was large text items, we discovered very, very quickly that Mongo has a hidden 16 megabyte limit when you're using their cloud system. That was fun. We discovered that the hard way when we tried to write 16.1 megabytes to it. So then we started to split documents by storing documents by cross-referencing. So we had an ID that became the head, and we then had a sub-document ID that was put in order numerically, and we just rejoined them in memory. At one point, the largest server had, I think it was 4 terabytes of RAM. And on one occasion, it did actually run out of RAM, which is a lot of data in memory. That made for very, very fast searches.
There's actually a feature in Mongo which is called GridFS.
Yes, that's what exactly what I was
Literally which actually just chunks, if you got like things which are a bit bigger than, I think it might be 32 meg now these days, or 16, whatever it is. Most things aren't going to go that size, but if they do, they've got like a feature called GridFS, which you throw the data out, it just chunks it into parts. And then when you query back out, you can actually query back out in chunks as well. So you can say, get me the third, fifth, whatever, a chunk of it. It'll just give you that as a blob.
Nice. That's GridFS.
Yeah.
I'm going to send them a message and tell them that exists. That'll speed up the system again for them.
Chris, how did the code ever get past the POC position? How did it make it from a POC to being production? And considering how many customers and how diverse the customers were, why was it never like totally detailed what exactly it would cope with before it went to production?
Okay, the politically correct answer to that is decisions were made that were bad. The non-politically correct version of that is, I can say this because the manager is no longer there, the manager seriously screwed up when he pushed it to production. He should never have pushed that to production, and it should never have gone live, and it was done when 3 out of 5 engineers were off. So
was that a Friday too?
Unfortunately, no, because that would have actually been blocked by the CI/CD pipeline at that point.
So was there no PRs on the pipeline to kind of stop it going in? Was there nobody there to check it?
Yes, there were. He also had admin rights.
Nice. That was nice.
So yes, it was an individual making some very interesting choices, shall we say. And it meant that he decided that was happening. And when that happened, too late now because customers are using it.
Did he at least buy the team a crate of beer or something, or take them out?
Oh yes, he was genuinely apologetic. He thought that he was pushing a production ready app. It would have been helpful for him to have waited for any of the senior engineers to be around, because one of us would have said, no, you never asked for this to be production ready. We won't talk about the day that I went back and noticed that the SSL certificate was invalid. That's the level of issues he was creating for himself.
Nice. That sounds cool. Absolute nightmare.
Yep.
Yeah.
It was most definitely a nightmare, but it was one that we resolved, and we could fix the problems, which at least fixing the problems meant that, hey, I learned a lot in the process, and so did a lot of the team. And most of the things we learned was how to manage with sleepless nights and still work a full day.
I'm guessing the kind of the identification of the patterns that was coming through from the customers must have been a massive kind of win, I suppose. And
yeah,
you start to see some structure within it that's getting thrown at you.
Yeah, so when we first started looking at the data, we were just looking at the data as a whole, rather than going, is there anything for an individual customer, rather than just complete randomness. That's when we started to realize, what we're actually dealing with is customers who are trying to use data in ways that we never intended it to be used.
Yeah, customers do that, don't they?
Yeah. Customers are geniuses at finding ways of breaking your systems.
Yeah, it's always good. Very true. Yeah, fantastic.
Thank you very much for that. That was really good.
Yeah, thank you very
You're
much.
welcome.
Yeah, that's nice.
don't know if that was cancelled out, but there was clapping there.
Oh, I heard. Thank you.
Zoom's normally good at cutting that kind of stuff out. So.
Yeah. I'm actually been quite impressed with either Zoom or my laptop, but there's no way this microphone from the laptop, unless it's no, it can't be getting anything from the HDMI, right? So it's just cancelling out. Surely the feedback would be way worse than us talking from a distance. But yeah, it's been pretty good. You haven't heard your own voice coming back, have you?
On one occasion, yeah, but that was while somebody else happened to speak at the same time. So basically, it uses noise cancellation behind the scenes. So Zoom actually uses an AI-based noise cancellation. It listens to two streams at once and cancels them out with each other.
Yeah, it's interesting. Yeah, good stuff. All right, well, if that's it, then yeah, say goodbye to you. I'll shut this off. I can talk to you afterwards if you like.
Yeah, no worries.
But I'll stop the live stream. So goodbye, YouTube. And yeah, I'll chat to you in a bit. Thank you very much.
Right, speak to you later.